So we've talked about inputs and outputs, and the big input output project that was the chatbot. The input there was the sound sensor, and the output was triggering the motor. I'm going to show you an even simpler input output project that can be used to explore the microbit and make it and use it with our little board here, and also gives us an opportunity to explore a very rich concept of switches and buttons and how those are everywhere. It's a great project for makerspaces as well, because buttons are built into just about everything out there in very innovative ways. And once the students understand how simple a button is or a switch is, they can find their own ways of making their own buttons and switches in very clever ways. So let's start with coding a project that explores these buttons, and then we can talk about some different ideas and different ways to take this. So let's start with the very idea of what is a button or a switch. I have here a little circuit diagram I got from SparkFun that it's an animated GIF. You can see here that the top part up here is the button, the thing that opens and closes. So what is a switch or a button? Quite simply, it is the opening and closing of the circuit. Every time the circuit closes, the power can go around and turn on the LED. This triangle down here represents an LED. This little zigzag represents a resistor. We don't need to know that. I'm using this just to show this idea of a switch is really opening and closing a circuit. Once we understand how basic that is, we can use that switch or button in many different ways. Now let's go to our code and figure out how do we build code that uses the button. So I'm going to go back to the main window and open a new project. I'm going to call this Button Exploring. Now, because we are working with our little monsters, and because I want to have a clever output here, I am going to have it both have an output. I'm going to go back to this idea of using the faces of the monster as my output. And since I'm starting with a fresh batch of code, I'm going to come up with two very basic faces that I am not going to bother writing a function for, but I am going to make that face here. I'm going to make a happy face and I'm going to make a sad face. So first I have to add, because I like to use the NeoPixels when I do faces, because they're the eyes and they can be very expressive, I'm going to go to my extensions. I clicked on the extension tab. I'm going to go to NeoPixel and I'm going to add the NeoPixel extension. Every time I add the NeoPixel extension, I first initialize the strip on set strip to NeoPixel at pin. Remember, the eyes on our bit explorer are on pin 16. So I'm going to say pin, and I scroll down to pin 16. And right now I've only got two eyes here. So there's only two eyes, and leave the rest of it alone. It's as RGB format. So I've set two eyes as RGB format. So now I'm going to play with this input and output. Now let's go back to our input blocks. Let's go the most basic input and the button A pressed. So let's say that forever this monster is happy, and I'm going to create a happy here, and then whatever our input is going to change how it's feeling. First, I'm going to create what happy is here. Happy, I'm going to go to the NeoPixels. I'm going to show color. I'm going to say green because its eyes, the colors are green. I'm going to go back to show. Remember to click on that show. Don't know why, but that has to happen. And then I'm going to add a smiley face. So, of course, I just did this on button A pressed. I'll drag this all over to the forever. And I'm going to say, okay, so here we are. Got a big smiley face that forever, the eyes will be green and the face will be, there'll be a smile on the face. Now, I'm going to take this same code here, and I'm just going to copy it. So I'm going to Control C, Control V here. And now under button B, I'm going to say every time I press A, it's going to be sad. So this time I'm going to make the eyes red, and I'm going to put a sad face. So every time I push A, it's going to be sad. The eyes are going to turn red, and it's going to be sad. Now, one thing to look at here is because this is on button A pressed, and this is a forever loop, it's going to always quickly go back to being happy. So just to make it be sad for a little bit of time, I'm going to put it pause here. I'm going to say be sad for 1 second every time I push A. I'm using the button that is built into A. I've plugged in my microbit through the USB cable, and now I'm going to hit download. Here's my guy. Here's my little monster. He's sitting there happy. I push this button. Oops. I pushed that, and he said, well, actually, that didn't even pause for a second because it automatically went back and forth. So that forever loop is a pretty aggressive loop. It automatically goes back and forth, and that pause didn't even pause that because it automatically went back. So let's see. That's frustrating. So because that forever loop is so quickly jumping in, I might want to instead put in that forever loop an if-then statement so that it's waiting for one thing or the other. I'm going to go back to my code, and we'll see how this builds up over time. I'm going to go back to my code and make a quick modification here. So you see in that example, that forever loop is always jumping in and going back to happy. Even though it quickly registered being sad, it did nothing there. I'm going to instead put in a logic here that if something is true, then do this. And I'm going to put the button is pressed. So instead of the button pressed block, I'm going to go back to my input and use the if button A is pressed, be sad. I'll go back and add my pause again. Let's see how this works. This one should work better because this forever loop isn't just running along in the background, jumping in all the time. Here it's going through a few steps. It's, if this happens, do this, and then go on to the next thing. So let's see what happens if I download this code. Oops. Connection failed. Sometimes my microbit does not seem to. Let me unplug my microbit. Turn it off. Okay, I've got to unplug it. These microbits are giving me grief. All right, let's try this again. I'm downloading again. If you want to see what I'm doing, download. Okay, so go back here, plug in my microbit. This thing seems to be tracking me again. Let me just stop that. Okay, I'll turn it back on. If I press A, it stays sad for a second, and then it gets happy again. Now we've written code so that when I press button A, it gets sad, and then it becomes happy again. Well, the buttons are built in, and that's interesting, but what if we want to have that trigger somewhere else? Let's explore that other option. So right now we use that if button A is pressed. But there are other ways of triggering something. There are other buttons out there that we can use. Go back to that input block, and you'll see that there's another option that if pin 0 is pressed. If pin 0 is pressed. What does it mean to press pin 0? It means we are somehow closing the circuit between pin 0 and something. When we press pin 0, we are closing this circuit between pin 0, which has a positive charge, to ground. So if we connect pin 0 to ground, it's the same as pressing a button. And there are lots of ways we can connect pin 0 to ground. So let's explore that and go back to our code. I've changed the code. I'm going to plug it in. This time I'm going to disconnect my microbit, plug it in because it's been giving me grief. Download this here. Unplug it. Put it all back together. Go back to my document camera. Here I'm going to zoom in on this guy. Here's my microbit. Now remember, I had previously done A, but since I changed that code, A does nothing. So now I said connect it to pin 0. Well, one thing I want to show you is if I were to just unplug this and plug this in, here's pin 0, and you see that smiley face, and here's ground. One way to connect pin 0 to ground is through our bodies. Our body is conductive, so if I put my thumb here and my other thumb on pin 0, nothing's happening. So I'm going to lick my thumb to make it extra conductive, and I connect those two. Oop, there it goes. It connected. It just went sad on me. Guess I'm not as conductive. Oh, there it goes. It's sad again. So you see, my body just closed that circuit between pin 0 and ground because my body served as that switch that closed in that example. So let's get back to our little board here and figure out how can we connect pin 0 to ground. If I turn the board over and look at the pins here, we'll zoom in. On the back of servo A is pin 0 and ground. If I were to connect a wire to pin 0 and ground, I could, if I took, for example, this alligator clips, connected those to the back here, pin 0 and ground, turn it around, zoom out, and then touch this. Just by touching these two, I can now turn it on and off, closing that circuit and triggering that pin. So you can now see that I can extend this in a fun, interesting way. The students can connect it to something else conductive. They can explore what is conductive. They can take, for example, a aluminum foil and connect one end or the other. And when those two pieces touch, it suddenly touches. If you happen to be touching one end and then the other, you can trigger it back and forth. So this is an example here, connecting to the back pins, connected to pin 0 and ground, and the trigger, if we go back to the code as a reminder, all we were saying is that if pin 0 is pressed, what does it mean to press a pin, to push a button? It means you've closed the circuit. And closing a circuit is as simple as just pushing two wires together. That's how it's drawn in a circuit diagram. That's how it works. There are many ways to close a circuit. Like your body is conductive. You can take paper clips, explore pipe cleaners. You can explore all kinds of material that is conductive. Here's another interesting feature that's built into this board that just happens to work quite nicely with pin 0. If I turn the board over and you look at the back, you'll see that these circles are marked with different pins. Each one is conductive and connected to a pin. Therefore, anything that comes off of pin 0 and connects to pin and ground, you can close that circuit. So if I count down 1, 2, 3, that's ground. That third one down is ground. And the fourth one down is pin 0. Well, that means that something as basic as my touching my finger to these can trigger it. So just touching the side of the board now can trigger pin 0 and ground into something. We've talked about other ways of connecting it. Now that I've extended that, I can also connect this to Lego and use conductive tape. So I can take this, push it on, and if I cut these strings of conductive tape that are pulling off, if I do something that then makes these touch, every time the two pieces of conductive tape touch, it's now triggering that button. So this simple concept of a button or an on pressed allows us to do a lot of interesting exploration of inputs and outputs, because that input can be very creative and interesting to whatever you are trying to do. And let's go back to our code and go into yet another example of how to go deeper in this. Now, this one is probably a little more than what those of you who are working with just the younger kids and the basic coding, but I want to highlight another way buttons can be programmed in the microbit by showing you this code. So let's go back to the code. And right now we're using the on pin is pressed code. Remember, there's another thing about on pressed, which assumes that it's down for a certain amount of time, but if it's and that you let go. And if it's down for too long, it doesn't work. So remember, we showed you before in the buttons another set of code that behaves slightly differently. If you look at this on pin 0 is pressed code, it only gives access to pin 0, 1, and 2 as being pressed using this block. And that's fine, because if we go back to our example with our bit explorer, 0, 1, and 2 are easily accessible. We can access them through the pins on the back of the board or through the front here. I can, just by touching these, something connected to those pins along the side can trigger it. Remember, like I was showing, very easy to use input buttons that use 0, 1, and 2. Just simply closing it works. Another button I sent some of you in the mail is this simple button that you push like this. In the case of the pin 0 example, if I go back to on pin 0 press into my code, I can show you how you would connect a formal button. So this is just a push button. A push button is the same thing as what we had before. It's just an opening and closing of the circuit. And so it will work just like it was when we were touching it. To connect this, we're going to go to the back and find connect one side to the ground and one side to the pin, so that now that I've downloaded this, I'm going to turn this back on. Every time I push this button, it will trigger it. Now you can see that a button can be a formal button like this one, which is fun. It's easy to build into something. Kids can do it. You can take something like this. This is very easy to build into cardboard. These buttons also unscrew from the back, so that if I make a hole in the cardboard, I can easily connect this to the outside, and they have a very robust system for the monster. You don't need to use a formal button if you don't have a formal button. But a button can be, if you're looking for something that has already pre-built, super easy UI, use the button. All I did, connected the same button. It doesn't matter, because all it's doing is closing. There is no positive or negative. It doesn't matter which side you plug it in. One side goes to the pin, the other side goes to the ground. You are closing the circuit, and that's how that works. And so that is the basic way of doing that. Now, another button or thing I want to show you is these buttons work by these particular buttons. The buttons on the front, we connect through the pins. The buttons work by connecting something from power to ground, and from the button to ground. So it's waiting for that circuit to close. That is how it's functioning. There is one other button here. And if you've ever worked with things like the Makey, you have experience with connecting something from a button, a pin, to ground. That's how the Makey works. You always need to connect to ground with the Makey. There is one kind of button that does not need to be connected to ground, called a capacitive touch. It works on the fact that your skin is conductive. When two conductive things touch, it'll trigger it. I've told you before that this logo in the front is capacitive. Let's explore the code of how we can use that. So right now, here's our code. I had this on when if pin 0 is pressed, but I can also go to the input options and scroll down. So remember, these are all the inputs. We've done the shake, the different gestures. At the bottom of our input pins on the first input tab is if logo is pressed. The logo, like I said, is a capacitive touch sensor. So I'm going to move this pin 0 is pressed off to the side and put in there instead if logo is pressed. So I'm going to now plug in my board, download that. And it's downloaded. So now, if I go back to my down-facing camera, here it is. I had it hooked up to the button before. Now the button does nothing. But I said if I touch that logo, something should happen. So now if I touch the logo, you see it changes. Touch the logo, it waits. It's sad for a second. So something as basic as touching the logo can trigger this monster here, and it can make it sad. So if I touch it, oh, it's sad. Think of that as a button, but a button that doesn't need to have a circuit closed just by touching it. It's a very sensitive. And often when you see anything that says it's capacitive, it means it doesn't need to connect to ground. It doesn't need to, like all these other buttons, we have to connect the pin to ground, just like in the Makey Makey. And I think Makey Makey even released a version of their board once upon a time that only had one or two things that was purely capacitive, that you could just touch it and you didn't have to connect that second thing to ground. Sometimes people get frustrated, like, why do I have to always be holding one end to trigger the other end? In this case, we are using a capacitive touch sensor to trigger. This capacitive touch sensor is that little logo on the front. And leads us to another project I wanted to show you. We had earlier talked about one way to introduce students to the microbit and coding was the chat box. It's fun. You've got this input, which is sound level, and then the output was the motor moving. Another variant of that uses a capacitive touch sensor is the TickleBot. Google microbit TickleBot. You'll find a tutorial made by Jasmine Florentine, who did this cute little TickleBot project using the microbit and the capacitive touch sensor. This is a very simple input-output project that you can also explore with all the stuff in your same kit. And it's another way of building upon inputs and outputs, but staying super simple with just the buttons and inputs, the inputs being effectively a switch, a button that we use. I wanted to highlight that and explore other ways buttons work before we dive into the AI world, which we will be doing in the next hour. So I'm going to break for now and let you folks explore some of that. When we get back, we are going to jump into exploring AI with the microbit and how we can teach AI and use AI with it. I took that same code. I'll show you the code that I did for this when we restart. Super simple, but we can use this same monster that I've built here and turn it into a TickleBot monster. And you might even want to start with a TickleBot instead of a lip syncing one, because this one's quieter in the room. You don't need music blaring or people talking to trigger this. You can just have it laugh every time you scratch it. And you can see from the link I'd shown you before, it can also be hands that wave and tickle. It can do lots of different things.